Conservation of energy and power. The conservation energy principle is that energy is always conserved. Energy can be transferred usefully, it can be stored or dissipated, but it can never be created or destroyed. When energy is shifted between stores, not all of the energy is moved across usefully into the store in the way you want it to be. Some energy is always dissipated when an energy transfer takes place. Dissipated energy is referred to as wasted energy. This is because the energy is being stored in a way that not useful. Let's take a look. Mobile phones. Mobile phones are systems. When you use the phone, the energy is usefully transferred from the chemical energy store of the battery to the phone, but some of this energy is dissipated in this transfer to the thermal energy store of the phone, which is why it may start to feel warm when you have been using it for a while. It is handy to be able to describe energy transfers for closed systems. Here is an example of how to do this. A cold spoon is dropped into an insulated flask of hot soup, which is closed and sealed. You can assume that the flask is a perfect thermal insulator, so the spoon and soup form a closed system. Energy is shifted from the thermal energy store of the soup to the useless thermal energy store of the spoon. This causes the soup to cool down slowly. Energy transfers have occurred within the system. However, no energy has left the system, which means the net change is zero. Power is the rate of doing work. In other words, how much per second. Power is measured in watts. 1 watt is equal to 1 joule of energy transferred per second. You can calculate power using these equations. Pause the video if you need to. A powerful machine is not necessarily one which can exert a strong force. A powerful machine is one which moves a lot of energy in a short amount of time. Let's take a look at an example. If you take two cars that are the same in every way apart from the power of their engines, both cars then race the same distance along a straight racetrack to the finish line. The car with the more powerful engine will reach the finish line faster than the car with a smaller engine. In other words, it will transfer the same amount T of energy but over less time.